How's it going? Welcome to Large Data Bank. It's good to see everybody. Sorry for the little bit of a late start there. Hope you're all doing absolutely fantastic. I missed you. That's what I have to say. I was, last week, if you guys tuned in, you might remember we did a little bit of a weird stream. I was outside. I was talking into my cell phone in the streets of New York City. It was super fun, but I missed the home environment. I missed the programming. I missed Hydron Compy. So that's kind of what's up in my life. I don't know. It's kind of hot. It's been a beautiful day this week. Beautiful week this week. Every day is really quite cool out, I have to say. Really, really nice outside. And then today, well, it's back to hot. But what do you expect? It's August, right? Yo, Anthony, what's up? How is it going? I love that bongo emote. Very good. Very awesome. Yeah, so, I mean, man, I have to say, it's been a social week for me. Extremely social, out of control. Last week, if you remember, I was walking through the streets of New York City. Why? Because I wanted to see my coworkers. Super fun. Haven't seen those coworkers since the beginning of the pandemic, basically. So it was really fun. We, got some breakfast with some people, got some lunch with some people, had some happy hours with some people. Really, really nice. And then, yeah, I had a week. Today, I actually met up with some coworkers in the morning too, which it was pretty nice. Somebody was in town, so we got together. We did some whiteboarding and stuff like that, just chatted. It's really nice, really nice. It's good to see people that you work with. We were kind of thinking like, it kind of feels like, yo, Rail, what is up? Welcome to the stream. We were kind of thinking it feels kind of like having that in person. You can last for a long time with a little bit of in person, right? It's kind of like gassing up. Seeing people, it kind of fills your tanks. You talk a little bit about work, you talk a little bit about social, just getting that bonding, it really, really helps for people who work with each other all the time. So I don't know, I think that remote work is awesome. I'm a big fan. I love my little setup here, and it's hard to imagine life before remote working for me. But I feel like there's something to be said for occasional in-person tank fill-ups, if you know what I mean. I don't know. What do you guys think about that? Are you pro tank fill-up? Are you more like just, keep me away from people? I guess it kind of depends on who you are and what your working style is. But for me, it's gotta be like remote plus some in-person gas ups. That's kind of how I feel. So yeah, that's kind of what's up. I don't know. Let's see what else happened exactly. I got some books and I read some books. That was kind of fun. Did you guys ever read? This is a beautiful book. A very nice looking book. Look how nice this book is. Look at it. God, this book looks great on a shelf. It's about, it's kind of about, I'd say it's kind of like a VP of engineering handbook, this book. An Elegant Puzzle, Systems of Engineering Management by Will Larson. It's kind of a good book, kind of some interesting things in it. It's pretty absolute. It's kind of like, this is exactly how things are and how they should be. I wasn't a big fan of that part, but besides that framing, I thought there was a ton of good tips, kind of really interesting thoughts about how to organize a technology company, how to make teams, when to split them, how to do different systems, how fast to grow different parts of the company, all sorts of different things like that. It was kind of nice. It's like part of these things you've heard before if you've worked at a company, but it's nice to see them kind of presented from this top-down level, the way that it was kind of done here. And yeah, so I don't know. I thought it was pretty interesting. But I have to say that one of the best things about this book is, God, just look how good this book looks. I mean, this is like a gorgeous looking title. And there's some like pretty graphs in here. Like, let's find some graphs. Let's find some graphs. What's a good looking, like this, for example. I mean, you gotta love a graph that looks like this, right? It's like the content of the graph, good, but the look of the graph, 10x million goods. Anyway, can deal with people, but I won't stand breathing in their gross long air anymore. Yo, save. Keep me away from people. Makes sense. Company party yesterday. Felt good seeing old faces, but just love the work from home setup as well. Yeah, absolutely. Absolutely. Yeah, man. So I don't know. That's kind of that. I don't know what to say. Next week I'm going on vacation. I'm going to Cape Cod. Really looking forward to it. I'm gonna eat some oysters. Gonna chill on the beach. Maybe fly a kite or something. It's gonna be nice. I haven't taken a vacation for a little bit, so yeah, it'll be really nice. I'm looking forward to it. Gonna have some fun times. Maybe I'll do another IRL stream for you guys on next Friday, since I won't be at my main computer. But we'll just have to see about that. Stay tuned. But I'll be on vacation. It should be good. And yeah, so that's kind of that. So for the stream today, what I wanted to do was look at a little bit of a performance. Yeah, crafting interpreters. That's a great point. I wanted to show that one off too. Another gorgeous book. Hold on a second. Thanks for, oh my gosh, you changed your name to be something that is easier to pronounce. But I still don't know if I can pronounce it because I don't know if you say the S at the end. Is it Matthews or just Matthew? But it's nice to see you again. I'll be right back. Let me get this book. Oh wait, it's actually right here. I don't have to go anywhere. I don't have to go anywhere. Check out this book. God, now this is a sweet book. This is a sweet book. I haven't read this guy yet. I read An Elegant Puzzle, and I read An Elegant Puzzle. I haven't read this one yet. This thing is a tome. I mean, it's a big boy. A lot of this stuff is available on the internet. I think it's all available on the internet for free. But like with a book like this, I mean, how can you not own something like this? Oh my God, this is another gorgeous one, and just such a nice thing, and some really nice, cool illustrations in this book. Like, check this out. You know what? Look at this. Class defines, provides, access, creates. Beautiful looking stuff. And who doesn't like writing language interpreters, right? I feel like that's a lot of what we do on the stream, is writing this big thing that we call the SQL compiler and the SQL executor. And it's really not too different from an interpreter. There's some elements of a compiler in there. There's some elements of an interpreter, but it's really all just so relevant. Building languages. I have to say that building languages, if you're a novice programmer or somebody who's coming up and trying to understand some elements of computer science, there's nothing better than learning to write a little interpreter, whether that's like a Lisp thing or like maybe some language of your own, or maybe following this book. I just feel like, man, it really like clues you in to a whole different level of what programming is all about. And I think you'll find that it's not as hard as you might think to write a little thing that can interpret a language. It's really, really satisfying, really fun. And I feel like it's on par with like writing a game in terms of like a self-contained little project that you can do. It'll be pretty tough, but it'll feel like it's got an endpoint. It'll feel like something that you can tinker and play with and make better over time. So I can't recommend writing interpreters more, just as like a fun thing. It's just kind of a fun thing that will also, you know, teach you stuff, basically. Yeah, so that's basically that. So what I wanted to do today, though, I wanted to work a little bit on a performance-related problem in the database. It's something that one of my colleagues noticed just earlier today, actually, and they said sort of like, oh man, I don't know, I might not get to this, and I just thought it would be kind of fun to try to attempt on the stream. I'm not sure how far we'll get or what we'll find exactly. I haven't really looked at it before the stream, so I don't exactly know if it'll be possible or anything, but I thought that we could try it. Do I have links to these books? That's a good question. I don't have them on hand, but let me pull them up here. Let me get the books here. So crafting interpreters. This would be the book, the interpreter book, Code Hakase. Here's crafting interpreters, and then we have An Elegant Puzzle. It looks like this is more of a blog post, but yeah, maybe I'll link you to this one. I think that I would recommend, well, I don't know. It depends on what you're interested in. I don't know if I would recommend this second book unless you're really trying to do like management at a big company or something like that. I don't know. I think it's cool, but I don't know how relevant it is. I think my favorite book on management, you guys, if I wanted to recommend my favorite book on management, it would be The Manager's Path. This book is really the best book about engineering management, by far the best thing ever. And I can't help but recommend this because it's just so fantastic to really give you a blueprint. And it's not even just good for managers. It's also good for ICs. It's also good if you just want to understand, how do I be a better employee for my boss? How do I work with my boss? How do I get stuff done? And stuff like that. Oh my gosh, I'm totally like try not to dox myself by showing you my Amazon front page or anything like that. But yeah, anyway, I don't know. I think that The Manager's Path is absolutely a fantastic book. This thing, it's good. It's very different. The target is very different. It's not such a general handbook the way that Manager's Path is. So that's just my take on it. But also a good book. Also a good book. This one's completely different. This one's about programming, right? And I think with this, honestly, you might want to just start with the ebook, which I think is free, or maybe not the ebook, but like the blog post or something. It's like crafting interpreters. I think like a lot of this stuff is really just like on the internet for free, right? Yeah, this whole the whole thing is on the internet for free, so you can check this out and just read it yourself if you feel like it. And that is awesome, right? That is just awesome. So yeah, that's that, right? I'm having a minor technical difficulty though, which I didn't quite resolve. Not so experienced backend devs. What's my favorite book for not so experienced backend devs? I mean, my favorite book for beginner students of computer science would definitely have to be the original Structure and Interpretation of Computer Programs. This book is just such a badass book. I mean, it's kind of weird. This is a book about writing in Scheme, which is a Lisp-like language. But this will teach you also so much. It also has an interpreter project in it. And I mean, this was just such a fundamental book for me when I was growing up as a young computer science student. But it's sort of a little abstract. It's not exactly the most like immediately concrete thing. I also really like how to design programs. This is another really good book that is good for beginners. I think it's kind of a longer one, right? It's more of a textbook, but it's really, really good and really, really, I should compile these into a little command, I think. I'm going to make a command called, let's make it commands add CS books. Maybe I'll say beginner CS. Beginner, first CS books. I'm never going to remember this name of command. But anyway, I'm going to put, I'll link this HTTP thing, and I'll link this SICP thing, I think. Best database books. I mean, whoops, I've got DB books for that. I think designing data intensive applications. God, that's just such a classic. This database.dev is good. I don't know. These are my opinions on DB books. But yeah, so I don't know. That's that, you guys. Anyway, I was going to say I'm having a little bit of like random irritating technical difficulties, to be perfectly honest, trying to get my IDE to boot up. For some reason, it's like not really working. I don't exactly know what is going on with that, and it's actually going to be kind of a problem if I can't figure it out. So yeah, basically I feel like make a command to list all the commands. I do have that one. That's called commands, I think. But yeah, I'm having this problem. Basically, all right, I don't know how to fix it, honestly. So if I go over here, and then basically the way you're supposed to start this thing is you're supposed to do it bin golang.sh, and then it just hangs. So like, I don't know what to do. I was thinking right before, that's kind of why I started the stream late. I was like, oh my God, how do I open my IDE? I actually don't really know what to do here, you guys. And maybe I should just reinstall it. Golang, Linux. Maybe I'll just try that. Whoops, that would be this guy. Good old Vim. Yeah, I don't know about that. I think that'd be kind of tough. Okay, so we'll re-download this thing and we'll see what happens. Maybe that'll fix it. If it doesn't, I don't even know what we're gonna do, but that is okay. We'll figure something out. Sometimes you get technical difficulties, with basic stuff. I don't know. This is kind of what you get for running Windows WSL2 for all of its goodness and for all I like it. I do feel like sometimes it will do random stuff that makes no sense, but that is just what it is. So we're gonna go like this. We're gonna move. Actually, we don't even need to do that. We're gonna move WinHome downloads, Golang 20.2, 20.21.target.gz. We're gonna put this over here. We're going to tar zxvf this little baby. Okay. We're gonna make sure that it's not somewhere else running on my system, which would be kind of weird. Kind of like weirdly is, but DB books. Yeah, what's up, interesting lad? I just have this. I've got this little command here. I really like designing data-intensive applications, which is that second link. I feel like that's not exactly a database book, but it's really got all the fundamentals that you need to know about databases to be a good citizen in the world of like services or whatever these days. And I really like this database.dev thing is kind of more of like a, it's a sort of new style intro course to some of the principles of databases. Andy Pavlo's YouTube videos are really, 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 really good, really funny and really good. And the middle one is this UChicago course that I had the pleasure of taking when I was in college. So that's kind of that. Those are my recommendations. So let's go ahead and enter this directory here and see if we can. What does the install say? Unpack and then run cd bin, run golang.sh. Let's see if this is going to fix things up. Of course, it does not fix things up. Why would that be? Gosh, that's... I wonder if it's something like... something about my X410 or something like that. Interesting. Lad, thank you so much for the follow. Redbook.io. What is that? Readings in Database Systems 5th editions. Oh, yeah. This is supposed to be really, really good. I need to have a papers list. I mean, I do have a whole papers list that I haven't really popularized on the stream, but there are so many good papers that I've read. It's just they're kind of like hard to get into. Maybe this Redbook is the best way of getting into like database research papers and stuff like that. Not exactly sure. But let me quickly do something off stream here. Man, sometimes these technical difficulties will just get you, you know? It's just sometimes it happens. I don't even know. Maybe something like this. Maybe something like... You know what we could do? I mean, I'm sort of loath to do this. But what we could do is just run the IDE from the Windows side. Concise papers link, DB readings. I guess we could just try that, honestly. Man, this is annoying, though. I probably, like, have to restart my computer or something god-awful like that, right, guys? Who remembers restarting computers? I feel like I shouldn't restart my computer because that'll kill the stream, you know? Oh god, but all the key bindings are different. Oh no, guys, I don't know what to do.
Everybody knows that relational
Yo, Thanon, thank you so much for the Prime subscription. I really appreciate that. Gosh, I'm like hobbled though. I don't know what I'm gonna do. I don't know what I'm gonna do. I feel like this is not gonna do. We have to find a way to get this this X server thing working again, or whatever the heck is going on here. Let's see if we can debug this. This is gonna be a really exciting stream if we just spend our time debugging like whatever is going wrong with this thing. But you know, it is what it is. So like, what all happens? Do we end up getting down to here? I feel like we don't even get down to here, and we get stuck somewhere higher up. I feel like that's got to be what's happening here. So let's just go ahead and say, maybe we'll just echo hi. Who likes to debug shell scripts? You know what I mean? It's like so fun. Okay, so we do get down there, which makes sense. So let's go ahead and echo this entire command instead of actually running it. Maybe that'll help us figure out what's going on here. Okay, so we run some giant command here, and let's see if anything is still running with the Go stuff. It looks like it isn't. Set-X. I think what I'm going to try to do is just run this and see what happens, right? It's going to go like, well, bam. And so then this thing just doesn't do anything. So what do you guys think is up with this? What do you guys think is up with this? What the heck is this about? It just sits there doing nothing, dude. I find that to be completely unacceptable. I find that to be completely unacceptable. And I have no idea what to do. Okay, well, it looks like the JVM actually runs, because if I give a different class, it doesn't run, right? So that's at least kind of cool. But then when I actually go to do this thing, it doesn't do anything. And it's got to be because of the fact that I don't have my Windows server running, which is really important. If I run that, I think I did try this already, and what happened was that nothing happened. It does the same old thing. And of course, nobody's going to have any idea what's going on here, because why would anybody have any idea about this stuff? I have no idea. And what can I say? Maybe there's some logs to look at or something like that. God, this is awful. Who's ever heard of a broken IDE, you guys? Who's ever heard of that? Log for JF Penders. Who's been a enterprise Java programmer before? Who has been an enterprise Java programmer before? You have something called a logder. Is there some logs in here or something like that? Some logs over here or something like that? God, this is just such a terrible mess, honestly. I don't even know what to do about it. I wonder what would happen if I used... So there was this other X server that I was using for a while. Maybe like this VCX server. Maybe if I close this guy and use VCX server or something like that, it would fix things. VCX serve, right? It's okay. So VCX serve is now running. And what happens if I now run this like this? I bet it's going to do the same thing, which is absolutely nothing. Oh, it's doing something. Okay, so it kind of worked, but now it's really small. It's really small. Well, that's at least an improvement, right? At least that's an improvement. So let's close this. Let's close this. Now that we know that works, let's try to use our old installation of the IDE. Okay. Hey. Okay, we did it. I don't know what happened there. That was truly brutal. I'm very sorry about that, but we should be good to go at this point. Okay, so now onto the project. Onto the project. Just a little bit of irritating debugging sometimes happens. Okay, so let's go ahead and check out our issues in the GitHub here. Let's do this later. And let me show you this issue that we were talking about. So here is the issue here. So let me explain to you guys what's going on with this. So CockroachDB architecture. If you guys remember, here's the idea about CockroachDB. It's a SQL database that's distributed, that's separated into two major parts, SQL on the top and KV on the bottom. The way it works is that there's a SQL parser, compiler, query planner, and execution engine that translates SQL requests into KV API requests, like delete a key, get a key, scan a range of keys, update a key, that kind of thing. So that's what CockroachDB is all about. It's this big old distributed SQL thing that lives on top of a distributed key value store that also has transactions. There's a lot more to it, but that's the very basic architecture. And so the thing that you have to know about this picture is showing us something interesting. It's showing us a flame graph of a CPU profile of a Cockroach database that's acting slower than we were expecting. And what's happening here, so, with flame graphs, you guys know how to read these things. It's basically like this top guy is like how much CPU is getting used overall. And each of these chunks is like, maybe this thing is using 30%, this little guy that I'm highlighting here with my mouse. And you can kind of keep going down, seeing the percent that's used by each like stack frame. Each of these things are stack frames. So if you stare at this like flame over here, basically what you're going to see is that, there's kind of a fat flame that, goes down pretty far. Like maybe there's a chunk used here and join reader next input, that's kind of significant, this little part here. But the really significant part is down here. You can see it's pretty fat until all of a sudden it goes to 0, and it's all in this thing called kvcore.next. And so Nathan here, my colleague, found that kvcore.next. He kind of noticed this. This is like, it's a little suspicious. Anytime that you see a pretty fat, like, flame chunk that is just sort of random, you kind of wonder, like, why is this thing using so much CPU? Really, the only thing that you should be using a lot of CPU in the database are things like, you know, decoding the data from disk, or doing a, I don't know, hash join algorithm, maybe. I mean, maybe not even that. It's really mostly the stuff about decoding and encoding. That tends to be the most CPU intensive part of the database. Just encoding stuff, I would say, in general. The redness of the block, I don't think it actually means anything. I think it's actually just, it's just there for fun, just to kind of help you distinguish lines from each other. That's kind of a common thing. It just makes it look pretty. There's no real meaning of the redness. So the question is, what is kvcore.next doing? And so I'll just quickly explain the overall architecture. I mentioned, right, there was a SQL layer and a KV layer. All of this stuff up top is SQL. And kvcore, this stuff, all of this stuff down here, it's actually the client library of the KV layer, right? So I mentioned SQL's translating things into KV. And so just like any other API service, you probably will have an SDK of some sort, or like a client library that you're using to assemble requests, send them back, and receive the requests and stuff like that. So what kvcore is literally just the client library for the KV layer. And so it got us thinking, like, well, what the heck is this client library doing? Can we do better here, whatever is going on? So we investigated, Nathan investigated, and he noticed that basically kvcore.next, if you read through this thing, it's basically just saying that kvcore.next is getting called in a sort of n squared manner. It's doing some stuff, and we're going to dive into it and try to optimize it, get rid of that n squared, hopefully. And hopefully what we can see is that it's also, and the n squared, just want to be clear, what is the n in the n squared? That's another important part of CockroachDB's architecture that you have to know. It's all about ranges. So in CockroachDB, at that KV layer, all of the data in Cockroach is split up into ranges. So it's just arbitrary chunks of sequential data. Like a big chunk of sequential data, that's a range. And the range is the unit of replication and distribution. So if you have a 1 terabyte table, it's going to be chunked up into some chunks of 256 megabytes or something like that. And each of those 256 megabyte chunks have their own replication groups, their own little raft group, their own separate nodes that they can be replicated to and stuff like that. So let's say, for example, you had a request that had to send to 100 ranges, right? It had to get something from one range, something from another range, something from another range. That is the n in this n squared algorithm. So if you had 100 ranges, then there's going to be a 100 squared kind of loop going on in this thing. And we're going to try to get rid of that O of n squared in the number of ranges because we think that it is pretty bad. Got it? Any questions? What is up, Linux in 8789? I hope you are doing fantastic. Hope you are doing fantastic. So let us go ahead and dive into things. KV Quard. Okay. Okay. So let us see. So the function that we wanted to look at here was called kvcore.next. So is there some sort of next thing here? Here's prev. So presumably next will be around here. Here's next. Here's next. So what is even this calling function? This is divide and send batch to ranges, a very important function. So divide and send batch to ranges is the function that takes a batch of requests, like maybe a bunch of gets or a bunch of scans. It figures out which ranges all of those requests should go to, and it groups all of the requests by range. And then once everything's kind of grouped up by range, it sends those requests out range by range. So that's what this function is doing. And that's where we actually think some of this inefficiency is coming from. Because I think what's happening is there's a loop over the ranges, and then inside of that loop over the ranges, there's a loop over all of the requests or something like that. So there's something a little bit messed up. Yours sounds more exciting. Fighting against Avro and Python today, no Golang. So it's like Postgres cursor sharing. I don't know what cursor sharing is, but I suspect that it's not quite that, because it sounds to me like that would be reusing a cursor for several requests, whereas this is more like This is more like, let's say you have a big sharded database and you have some requests to get from each shard and you have them in a big batch. This is really just, let's group all the requests by shard and send them in little mini groups that are just for the shard, if that makes sense. Using the same cursor for multiple requests. Yeah, it's not exactly like that. It's kind of just more of like it's just sort of like a batch API that debatches things and batches them in a better way, if that makes sense. It's kind of like a batch slicer upper and reassembler machine thingamajiggy. So let's take a look at the code, huh? Let's take a look at the code. Divide and send batch to ranges. Sends the supplied batch to all the ranges, which comprise the span specified by span. Who calls this thing? DistSender.send. And it's getting called with rs, and rs is keys.range, the minimal key range encompassing all requests contained within. Okay, so what this does is it takes it's kind of interesting. I mean, this is even kind of an odd thing. It goes through each of the requests and it makes a mega span, the minimum and the maximum. So it could be like the whole database, basically. I don't think that we would see that showing up, but I don't know. We might. I guess we don't in this case. Right. So we get this thing. We got a big span. This thing is, I mean, more or less useless, honestly. It's just a huge range. And the batch request is trimmed against each range, which is part of the span, and sent either serially or in parallel if possible. Batch IDX with commit. If it's valid, if it needs another, some fast paths, unsplittable, bunch of preamble, channel of responses. Okay, so this is where we start to get serious. We're making a list of response channels per range so that we can parallelize this stuff if we can. We defer some function where we combine the responses. Okay. We check if we can parallelize. So here's where things sort of kick off. Iterate over the ranges that the batch touches. The iteration is done in key order. The order of the requests in the batch is not relevant for the iteration. Each iteration sends for evaluation one sub-batch to one range. The sub-batch is the union of requests in the batch overlapping the current range. Each iteration sends for evaluation one sub-batch to one range. Okay. The order of requests in a sub-batch is the same as the relative order of requests in the complete batch. Sort of requests in a sub-batch. Okay. On the server side, requests in a sub-batch are executed in order. Depending on parallelism, sub-batch, limits. Okay. So my first question is, what is this actually looping over? It's a new range iterator that takes in the DistSender, which is the object that we're a part of, and it does a seek to a seek key. And interestingly enough, seek key is actually the start of this mega range thing, which is a little suspicious. I actually kind of wonder, yeah, how do we choose the seek key here? The seek key, oh, you know what's interesting is that the seek key is computed by this next thing, which is exactly what we've been looking at optimizing. So I think essentially what we're doing is we are looking for the next key in the list of batches that we're looking for, so that we kind of skip. Okay, so essentially, like, imagine we have a request like that comes in like, hey, Yahor, what is up? We are seeing if we can hack on the next and truncate inefficiencies. Yes, exactly. I checked with Nathan, and I said, hey, Nathan, would you mind if I took a look into this on the stream? And he said, yeah, go ahead. I wasn't going to look at it anyway. So I'm not sure how far we'll get, but I thought it would be kind of fun to check it out, considering I haven't really dove into this stuff before. So let's say our ranges kind of look like this. A through C, and then we had like a G through, I don't know, M or something, and then a Y through Z. I think the idea with this stuff is that our initial RS will be A through Z. But hopefully this little iterator guy, this RI, since we're continuing to seek using the result of this next thing. Are you thinking about this a bit because you need to reuse it for the streamer? Well, let me know if I'm stepping on your toes at all, because I will certainly find something else to do. I don't want to get in your way. I'm happy to do something else. Yeah, I think the idea with this though. Okay. Well, don't hesitate. If it does become, you will be reusing next and truncate. Interesting. Interesting. Yeah, I think that, I mean, the key of this thing, not to overload the word key, but I think the thing about next is that it's being used in a really inefficient way right now, right? It's getting called the same way for every, it doesn't get to skip any work. And I think that that's kind of the fundamental problem here, because we're always restarting from the front of ba.requests. And so I might need to change. An interval tree could work well. I don't know if we need something that's so complicated as an interval tree. Do we? Oh, is this thing not sorted? If this thing isn't sorted, then maybe we would need something a bit more fancy. Is that the issue? Yeah, presumably this thing is not sorted, so we get into trouble. I mean, I would say that we could either sort things once up front, but yeah, I guess you have the same problem because these are all spans or something like that. I don't know how this stuff works at all, to be honest. Anyway, I think just to go over the quick idea, I think the quick idea here, RS is starting like this. These are our ranges, but they could be out of order. That's the main thing. And I think that what we want is on each iteration, we want to get the start key of the next range. So we want to start with A, then we want to get G, then we want to get Y, or something like that. We want to have a struct that is able to both handle both next and truncate, working on both at the same time. It does seem quite tricky. I haven't even looked at truncate yet. Next gives the left boundary of the union of all requests which don't affect keys less than the given key. The left boundary of the union of all requests which don't affect keys less than the given key. Okay. The left boundary is inclusive. That is, the returned R key is the inclusive left endpoint of the keys the request should operate on next. Informally, a call next BAK means we've already executed the parts of BA that intersects key min of K. Please tell me how far to the right the next relevant request begins. Okay, sure. What is this keys.adder? It's some kind of... Oh, is it like the meta range key that corresponds to a particular actual key or something like that? Something like that, right? I actually, whoops. What the heck is happening here? What is this doing? I want to quickly, let's not do that. I want to quickly download the CPU profile that we were kind of talking about here, because I would like to look at it. So give me 1 second to do that, because I would like to kind of see what is spending the most time with this stuff. Let me quickly go like this. Do 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 do. Okay, so we can go over here. Actually, quickly do this again. Just don't want to leak anything I'm not trying to leak. So just being a bit careful for a second. Sorry about this. Okay. All right. So let's take a look at this pprof here for a quick second. Let us just go. Why don't we actually just go ahead and pop it up in the web? So we're going to do HTTP localhost 8080. We can go over here, localhost 8080. All right. So what we see is here's this kvcore.next that we're staring at. And I just was sort of curious, like, what was the expensive thing inside of kvcore.next? And it actually looks like we're spending a lot of time in rkey.less. And this truncate guy is doing part of the same thing. It's doing, well, they're all spending time in keys.adder. They're all spending time in rkey.less. And they're spending some significant time in their own selves as well, which is kind of interesting. I mean, I suppose, here, hold on. Let's, I always wish that there was a way to have both the textual view for this stuff and the web view open at the same time, but I've never really been able to find a way to do that. So we're going to do lines. How does it work? It goes granularity equals lines. Peak kvcore.truncate. That's maybe a bit too complicated. Let's go back to functions for a second. Okay, so truncate is spending most of its time in flat. So most of its time doing a loop, I guess. And then a good chunk of its time doing each of these three things: keys.adder, rkey.less, and keys.isLocal. I mean, here's a question. What if we were to just literally like cache the result of all of these things, right? Like keys.adder is something that we could be avoiding to run so many times, right? Just by storing it in an array that is the same length as a union, right? That would be a very simple fix for this guy. Less we can't really do because we're always changing what we're comparing it to. And isLocal, what is isLocal for? What is isLocal for? Where is that even getting called from? isLocal is getting called from truncate. Oh, okay, so this is for truncate. I also wanted to look at kvcore.next. And for kvcore.next, we're spending time. Okay, that is fine. We're spending time doing rkey.less, keys.adder, adder upper bound, keys.adder. So this is expensive, huh? Why is this so expensive? I guess it does a bunch of has prefixes, huh? And it does some checks, and it does a little loop, and it does all sorts of complicated stuff, honestly. It's kind of weird. It's kind of weird. I mean, imagine if we were to just cache all that stuff, right? Would that be nuts? Or would that be fine? Like, imagine if instead of doing this, we were to simply call, we were to say next BA, comma, R keys, like this, BA, comma, R keys. And R keys would have the results of all of these things, or whatever. Would that be even good enough? I feel like that still wouldn't really help our problem. Really what we want to do is just memoize this entire thing somehow. And yeah, it's like, it is an interval tree, right? What is an interval tree again? Interval tree. Let's take a look at the interval tree data structure. It's a data structure to hold intervals. It allows one to efficiently find all intervals that overlap with any given interval or point. That overlap with any given interval or point. So yeah, I guess what you would do is, was there something like a sorted interval tree? Because we really want here is a sorted interval tree, right? Sorted interval tree. I mean, actually, do we even need to make a sorted interval tree? That seems really complicated. What if we were to just sort it by left key? What if we were to just sort it by right key? What if we were to just sort it by right key? Because we don't care. So here's something that I don't understand yet. Here's something that I truly don't understand yet. What does truncate do? Truncate is important for me to understand. It seems obvious. Truncate probably, does it edit the batch? Truncate restricts all contained requests to the given key range and returns a new truncated batch request. All requests contained in that batch are truncated to the given span, and requests which are found to not overlap the given span at all are removed. A mapping of response index to batch index is returned. So if I were to have the batch like this, put A, put C, put B, and the span is A to BB, it gives me back A and B in position 0 and 2. And what do we do with... Ooh, man, this is complicated, huh? This is complicated. This is complicated. It's no joke of an algorithm. It is no joke of an algorithm. So where do we get the partial batch? That's what I want to understand, actually. Where do we get the partial batch? The supplied batch. So here we have the BA. But it can't be the whole BA, right? What does this batch index do? This batch index. Oh my god, it's recursive. It's recursive, you guys. Oh, it's getting complicated. It's getting complicated. It is literally recursive, you guys. So it is not so straightforward. It's not so straightforward. It's basically saying, I have no idea what it's saying. It's saying, where do we do the thing where we pick out just the requests to send in the current, in a particular range? That's what I want to understand. It's recursive only in the case of range merges or range splits. What I want to understand... Truncate is that thing where we pick requests for the current range. But I'm confused because that happens after. It seemingly happens after we send the batch. Am I wrong? Here's needs truncate. Oh, no. You're completely right. Truncate the request to range descriptor. And it gives me back a new batch. And it doesn't edit the old one because it's a pass by copy kind of situation. Ah. And it gives me positions back. And then do I return positions or something like that? Positions gets returned in the response, huh? I see. I see. So truncate is the crucial thing for sure. It makes sense. And positions, so when we get positions back, Let's take a look at when we get positions back. Here's my resp. Where do I look at my positions? Where do I look at my positions? Yo, bro, Haunster, what is up? Indeed. The KV package. We're in the KV client. Does that actually count as the KV package? I feel like the KV client package should live somewhere higher up outside of the KV package, right? Right? There's no need to be afraid. We're working on this issue. Why don't I edit my project actually? Commands edit project. Trying to improve some O of n squared stuff. How about that? How about that? So here's an obvious thing that it seems like we're completely missing. Why don't we, when we get back our resp, how come we never look at the positions? Am I completely nuts? How come we never look at the positions? How come we never, do we look at the positions? It's in combine. Batch response combines each slot of the given request into the corresponding slot of the base response. The number of slots must be equal, blah, 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 blah. But here's my question. Why don't we simply remove the positions that we've removed from the request? Am I completely nuts? Am I missing that? Am I just missing that completely? A single request can span multiple ranges. I see. That makes sense. I guess like we could conceivably, what if we did something like this? I mean, it kind of just feels like we should be chopping up each of the requests as we're sending them out and removing the ones that we've chopped out, you know? And it seems like we don't do that. We just keep the whole thing immutable, which seems expensive. That's sort of part of the cause of the O of n squared. I mean, it's still going to be O of n squared-ish if we keep chopping these things down, though, right? It's like, it's O of n squared. The n is getting smaller, but we still have to do this looping, and it would be better to have a sort somehow. But it feels like we can't really do the sort because some people are like the interface kind of requests that you keep the sort for some reason. I don't really understand why that's important, but like over here it says where is this thing said again? BOGO sort? You could sort separate order slice? Yeah. But is it even so important? I just want to see what the contract really is. Order. The order of requests in a sub batch is the same as the relative order of requests in the complete batch. On the server side, requests in a sub batch are executed in order. Dude, I feel like the order, we have to return in the same order as the request came in. Otherwise, we wouldn't match the request and the response. Yeah, that's true. Yeah, that makes sense. That makes plenty of sense. That makes plenty of sense. So where exactly do we reassemble all of these things into the right spots? Is that in combine? Is that what you're saying? Is that what combine does? Make an empty slice of responses, which will be populated with responses as they come in via combine. Combine. Gosh, this is complicated. Combine combines each slot of the given request into the corresponding slot of the base response. The number of slots must be equal, and the respective slots must be combinable. So you could conceivably have a situation in which you really need to have, you have two responses from different ranges for the same request, and you've got to merge those two together, right? For each of the other batch.responses, grab the ith position. If the ith position slot in the, if we have nothing in one of them, then we just set it and we quit, fine. Otherwise, we run combine responses. And the result of combine is some like crazy stuff that depends on the thing. Okay, fine. It's kind of weird that we don't do this in order. How come we don't use this in order? How come this combine doesn't happen in order? That I don't quite understand. This just appends them. This just appends them. That I don't quite understand, to be perfectly honest. But you know, maybe it doesn't matter. Let's just okay. So let's carefully think. How would we be able to preserve the positions list even if we're deleting stuff from our input batch request? That's the ultimate question. That is the ultimate question. How do we preserve our positions list even if we were deleting stuff from our input batch request? I think the answer should be relatively straightforward. It's really just that we should destructively edit the input batch. And if you run out of a particular span in a particular slot, you just set it to 0, set it to nothing, and you change the loop so that if you see nothing, you just skip over it. So that's my proposed strategy. And we're going to see, I don't know what it's going to be like. but let's take a look at how truncate works and see what's up about it. So truncate takes an actual batch request. Are we allowed to edit these input spans? I just don't know. I just don't know. Like, for example, if we see a point request, right? Then I guess what I'm proposing here is that we would literally edit. We'd basically say, this is a point request. Consume the span or the request so that next time we can ignore it or something like that. I mean, the only thing is that even if we were to consume it, we would still have to iterate through it. But I guess my thesis here is that the iteration is actually really fast, and what's slow is all of the like random calls that we have to do to it, right? Like all this archy.less stuff. You know, this is what's so expensive, I think, more than anything else. But I can't really be sure. But I'm not sure if we're really actually allowed to mutate these requests. So perhaps what we could do is keep an associated side list of remaining stuff, right? You know, so for example, instead of iterating over ba.requests here, what we would be doing is iterating over ba. It's almost like a resume spans. It's kind of like an equivalent of resume spans, honestly. So what do we actually do here? Let's take a look. If we have a range spanning request, what if we keep the side list of R keys and set each element to empty once the span is fully consumed? Yeah. That does seem good, doesn't it? So we loop over ba.requests. We always call truncate one. So essentially we should be able to we should be able to skip a given request if it has been fully consumed. So the point is that we can't mutate these requests. So what we want to do is keep a side list. All right, well, let's make a little side list. Let's make a little side list. Let's jump over here. Let's, the very first thing that we're going to do, this is inside of send partial batch, which is interesting. I think what we'll need to do in that case is we'll have to thread this side batch through several calls, which is a bit annoying. But I think this is probably the top, right? It's just there's so many calls to this darn thing that we wouldn't want to start. We wouldn't want to create the list here, right? I don't really know. I think we need to. I think we need to create the list at a one higher level, and hopefully this is just called. I think this is a good use case for this view structure thing or call tree thing. How do I get a call tree from Goland? It's a useful thing, right? Navigate. Where's my call tree at? Call hierarchy. Okay, so here's my call hierarchy over here. And if I look at divide and send, I want to actually look at divide and send batch to ranges. Who calls divide and send batch to ranges? Let's take another. How do I get this? Control Alt H. All right, so it's called by an anonymous function randomly. Great. The anonymous function is inside of send. Divide and send parallel commit. Shift. Like, oh yeah, I forgot about shift. Good call. Or control shift A, I guess I can do, or whatever this thing is. What is it? It's yeah, actions. I could be searching for actions. Okay. So I've got this random anonymous function inside of divide and send parallel commit. So presumably I have to thread it into this guy as well, which is complicated. We've got to do it to send partial batch, which is a subcaller. So this is a recursive one. This is we'd already known about this, and this is send. So I think at send, I think basically we want to like put it right here. Create a list of the R keys of the start keys of each of the requests in the batch. We'll use this to, so here's the other issue with this whole strategy. Is that it's going to incur an overhead for requests that are small. Because this obviously gets used for every single thing ever. What is this parts? There's yet another loop. What is parts? Split batch and check for refresh spans? Dude, what is this? What in the world is this? What is split ET? This is the most complicated client library ever, huh? To ensure that we lay down intents to prevent starvation, always split the end transaction request into its own batch. Okay, well, I guess I'm just going to ignore that this exists and hope that it's fine. Oh, split end transaction. How about we rename it to be split end transaction? Well, I guess that's kind of complicated. Good God. It's deep. All right, whatever. I won't make that change. I'll just know. If the batch has its can forward read timestamp flag set, but is being split apart. admin requests are always singled out and mutating requests separated from reads. So here's another thing. We only want to do this optimization if we're doing a read-only guy, right? So that's kind of unfortunate. So I almost feel like I don't even know what to say, honestly. Let's go dive back into this guy for a quick second. I feel like we should do this from the inside out because I'm so lost, honestly. If we do this from the inside out, what it's going to look like? What is it going to look like? Let's go to truncate. Let's actually go to next. Maybe next would be the easiest place to start because truncate's complicated. Let's just look at a simple old next. And what could it look like if we were skipping stuff? The left boundary of the union of all requests which don't affect keys less than the given key, right? So let's take a look. Let's imagine that we had another slice. It's like a start key adders roach pb dot r key, something like this. If we had a, you know what we should actually do is instead of doing all this, what we should actually do is have a struct, or it's like a type it's kind of like a type batch request helper thing. Batch rec plus. I was going to call it batch rec plus for now. I don't know what it should really be called, but it's going to have a BA. It's just going to have a roach pb dot batch request, and it's also going to have my start key adders roach pb dot r key here. And that way we won't have to edit the signatures of all of these things, except for just changing this to be a batch rec plus. Batch rec plus. Okay. So once we've got that, then what we can do is say for I union in range batch request, right? We get to skip stuff completely. So we can say if BA dot start key adders of I is equal to nil, continue, right? Continue. We've already completely consumed the request at this position. Okay, so let's say that happens. Let's say that happens. What do we do about this situation, right? Because presumably what's happening is that as we are chopping this, now we have to go back and understand. So it's sort of like, Jordan, how do we represent a partially consumed batch request, right? So now let's go back to truncate and understand again what the heck is going on with this. Restricts all contained requests to the given key range and returns a new truncated batch request. So ultimately what we want to do is edit the given, we're not editing, but we have to represent the fact that we've edited the given batch request, the given request to chop out a particular span. But that's very difficult because the thing is that it actually can segment a, no, it always goes from the left. It has to go from the left because everything is a span starting from the left. So actually, I think what we can do is edit the left key, can't we? Can't we? Wouldn't that be kind of cool? So let's change this to be a batch rec plus. Okay, so if we see a point request, we consume the request so that next time we can ignore it. What we're going to say is, we have to have the I here, don't we? So truncate1 needs to have posts. Post int. We're gonna have a post int. We're gonna consume this request. So we're gonna say ba dot star key adders of I of posts is equal to nil. Great. So simple. We're dealing with a range spanning request is the hard case. So what do? We do some validation. We do a bunch of stuff. We do a bunch of complicated stuff. So what we need to know is what's the new left key? How do we do that? You see this? Check whether the truncation has left any keys in the range. If not, we need to cut it out of the request. So what's happening is that we're mutating the header. We're mutating the header, right? I don't know what this local business is about. I'm going to try to ignore it if possible. I mean, basically, it seems like if this is the case, we don't edit things. This is the case where we haven't sent anything, so we don't want to edit the start key that we already have. If we have returned something, then I think all we have to literally do is say ba.startKeyAdders of posts is equal to header.startKey. No, I guess it's header.endKey. Ooh, but we can't do that because this is the wrong type of key. Uh-oh. Well, that's confusing. What is that about exactly? I think what we want to do is make these regular keys then. And we'll try this. So basically, does this make sense? Okay, so yeah, so we're gonna write this down. Start key adders is the start key of the span of the ith request in the batch request. It's more than this. It's actually the start key of the remaining unsent segment of the span of the ith request in the batch request. So every time that we go through and we chop out some span of a given span, it always goes from the left. Ooh, except we have to be tricky because there's reverse requests too. Let's not forget about that. But for now, let's just think about everything chopping from the left. Then I think what we can say is we chop from the left, then everything, we can just delete all of that stuff from the left and set the new start key to the end key of the thing that we're sending. And we keep chopping that down. And then if it's nil, then we are good to go and we quit. And I think the last thing that we have to do here, we have to validate the end key somehow as well, right? So we have to say something like, I think it should be key. I think the R key thing is, so I think what an R key is the key of the range value for a key or something, but I would like it to be a key because that way we can map it one-to-one to the requests themselves. I think. I actually am not completely sure, but I would like to try it like this. And I think that the next thing that we have to be careful of here is that we have to say if we have to say No, wait. I'm so confused. We're making a header with the range key? What are we making here? I'm now lost again. This header that we're making here? I have no... No, I mean, I think this is making sense, but I'm not 100% sure. I don't know. Let's just the local end key. I just don't know what this terminology really means. The local end key should be truncated to the boundary of local keys, which addresses to rs.end key. Really don't know. Really don't know. Really don't know. But I think the main thing that we need to think about here is that if, I mean, this might be inefficient, but let's just say if header.endKey dot compare args, wait, not args, it's we're editing this header thing. This is a copy. This is a copy. This is a copy. So we need to say orig end key is equal to header dot end key. So we grab our original end key. And basically I just think that we need to say well, actually we can be very precise about it, can't we? We only edit the end key here. So we can get rid of this. We only edit the end key here. So I think what we do is we say, if we edit the end key, if we don't edit the end key, we're not editing the end key. This means that we're completely finished processing the span in the current request. So we consume it and can avoid looking at the current request for future iterations of truncate. So we can say ba.startKey adders of post is equal to nil. And otherwise we do this over here. Update. So we'll say next time we look at this request, we'll only have to consider the right-hand side of the span that we just processed, since we've chopped off the left side. Chopped off the left side already. Something like this, I guess. And the other key, I keep saying the key thing, that the other important thing here is that we have to edit the start key, the header's start key or something like that. You know, it's a little tricky. We basically have to say something like, over here, we basically have to say something like header dot key is equal to args of, we have to say header dot key is equal to ba dot start key adders dot posts, something like this. Set the header's start key to the remainder of the unprocessed, the remainder of the span of this request that we haven't yet processed. I don't know, just guessing. This really may not work, but we'll certainly try it out. We will certainly try it out. So we can get rid of this. Over here. Why is this different now? Oh, right. We're passing in posts. Has request. Truncate one. Truncate one. We should be able to skip a given request if it has been fully consumed. We need to add that part. So we need to say if BA dot star key adders of post is equal to nil, we just leave. We just continue. All right. Does that not make any sense? For each of the things, if it doesn't have requests, then we just do nothing. So we can continue just like this. Yes. Okay. Okay. So the next thing that we'll have to do, why is this not working fine? Cannot use trunk BA as the type roachpb.batch request. Does this need to return? I think this thing can just return the true batch request part since we're not going to be trunk BA dot batch request. I think we can just go like this, right? BA dot start key add post if len start key adders is greater than len BA dot requests. Yes, I think that's true. I think we need to make sure that they're exactly the same size, which I haven't done yet, but I think that's definitely important. Truncate BA. Oh, this needs to be like, crap. Let's just call this truncated batch or something. Truncated ba. Oh no, this thing, all of this stuff needs to be changed to be batchrec plus, I think. So we'll just have to start threading that through. This is going to be BA batch rec plus. And this thing is going to need to return a batch rec plus. Okay. So this is now, this needs to be a batch rec plus. So what is this? This is at the end, so we should pass it the real one. Prev. Geez. So what in the world is this thing doing? God. Preve gets the right boundary. God damn it. Okay, so we have to... Does truncate work in reverse true sometimes? Truncate can go in the other order. That is truly annoying. That is truly annoying. So I think what we should do for that is pass in is reverse to truncate. Right? How come I'm not finding Preve? Okay, so here's my send, and I think this is where we're probably going to start the magic, right? So we're going to right here, we're going to say but then really ideally what we would do is also cache it over here or something. So we're going to say like, this is going to be gross, 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 gross. So we'll just say something like, oh, but then there's like memory accounting to deal with, honestly. So let's say start key adders is equal to make roach pb dot key. Well, actually, we'll just say var start key adders roach pb dot key, and then only if we need to, we'll say if len. How can we like detect if this thing is made up of range requests or something? I guess it doesn't really matter. We'll just do it anyway. If len of cap of cap of start key adders is greater than or equal to len of start key adders, we'll say start key adders is equal to, oh wait, no, len of ba dot requests. Start key adders is equal to start key adders of len ba dot requests. Else make roach pb dot key len ba dot requests. Then we say for I in range ba. Right, except we don't know what the stupid start keys are. Start key adders of I is equal to, because we can't say bi of I dot whatever because we don't know what the heck it is. Ba dot requests, rather. We don't know what it is. We don't even have... Oh, wait, do we? Do we have its header? Oh, we kind of do. So we do have these keys, but these aren't always set, right? Anyway, we'll just go like this. I think that's fine. So we do this, blah, 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 bloobity, blah. Send it, send it, send it. This needs to be checked, changed to BA+. This needs to be changed to BA+. This needs to be changed to batch rec plus. This needs to be changed to batch request plus. Send to replicas. Send partial batch. Needs truncate. Set it. I think here we should probably send the ba.requests. Or ba.batch request, rather. Same with this one. All right. So now the next thing is that we've got to change truncate to not be broken in the space of reverse. So we're going to need to pass in truncate ba is reverse rs. So for this, it's basically, man, I think it's basically the same as this. Key adder dot less rs dot key. Key adder dot less rs dot key. Then we edit the key. I am so confused about this reverse stuff, honestly. So in the case of a reverse scan, I think the way it works is that the key is set to the end, right? The spans are kind of backwards, right? Or is it the other way around? I actually don't know. How does it work? Is reverse. What is this is reverse? Do we never use this? Oh, flags, reverse scan request. So a reverse scan request is the argument to the reverse scan method. It specifies the start and end keys for a descending scan of start, end, and the maximum number of results. Maybe, I just don't know. The starting key. The end key. It must order strictly after key. Okay, so it's always going in the right direction. I need to put some chapstick on my lips, so I'm gonna be right back. I am back. Lips rejuvenated. Okay, so I think the key thing here is that maybe we don't need to care about this. I actually think that we don't care about this. The start key is always ordered left, so we don't need to reverse. Everything's basically fine. And yeah, it should be fine. It should be fine. It should be totally fine. No is reverse. Goodbye. Okay, so then let's take a look at this next versus previous though. Like what is up with that exactly? Next, query next range. In the next iteration, query previous range. I think this is fine. I think we just basically ignore this stuff. It's not quite ignore. It's basically like, ah, right. So we look at each of the requests, and if it's nil, we leave. That's the point. That's the point. And the cooler thing that we could be doing here is that we could theoretically be, instead of using keys.adder of h.key, we could be using keys.adder of va.startKey adders of I. I think that's the main thing. So let's try that. And then furthermore, let's go to look at prev and see what it does. And we have to basically copy the logic. So we'll grab this. We get rid of this. We look at prev. It goes right boundary to the union. The end key. Right now it's looking like the end key. No, it's the same. It's actually the same exact thing. So we got to do I here. And here we're going to do va.startKey adders of I. And actually, why don't we extract this guy as a variable? Whoops. How come I don't know? Keep switching between keyboards so I get confused. Extract variable. Meta alt V. Meta alt V. Great. Okay, so we're going to replace all of these things. And we're going to call this start key. Okay. And we're going to do the same thing for next. So we're going to grab this guy. Grab this guy, replace all two occurrences, refactor. I'm going to call this start key again. Don't care about searching for comments. How do I turn that off? All right, so that's fantastic. And then I mean, honestly, I don't think we have to do anything else. I mean, I do think that this is probably going to be completely broken, but I do think that's like the main thing that we do. Why don't we just go ahead and like run some random tests and see what explodes basically? Should we do that, or is that like too wild? I think it's a little too wild. All right, are there any test cases that we should take a look at here? Probably, right? Probably, right? So let's actually finish our comment here. So no more R keys. Of the start keys of each of the requests in the batch. We'll use this to avoid re-examining requests that we've already examined. When we truncate the batch to a particular range, we edit the start key of the ith command if we've truncated the that ith command span down from the left. It's not command, it's actually request. If a request span shrinks to 0, we set it to nil. All right. I'm feeling like I just want to YOLO something. We're just gonna make build. Just gonna make build. We'll see what happens. What do you guys think? Prediction. Will this work or not? How do I do a prediction? Prediction. Will the database work after this change? Yes. No. Start prediction. Okay. Everybody put in your prediction. So basically what these predictions do is you can bet channel points. And if you win the prediction, then you get channel points from the people who got the other side of the prediction. So far, nobody's predicted any points. I might have to make a longer duration here. Somebody bet 10 channel points on one side. I think that might mean that you'll get nothing because there's no people on the other side. Okay, we're going to try to do more predictions in this channel, and we'll use a longer a time period next time. Actually, wait. Let's I guess we can't open a new one until that one goes away. But we'll see what happens with that, basically. Dun, dun, dun. Got to compile some JavaScript, though, naturally. Naturally got to compile some JavaScript before we do anything else. Gotta compile some JavaScript in order to do anything. It's totally normal. 100% normal, right, guys? Dude, the JavaScript compilation is so slow. I can't even get over this. It's unbelievable. The database is so much faster to compile than the JavaScript. I feel like I complain about this every time, and I don't know how to fix it. Kills me. It absolutely kills me. It absolutely kills me. Is it stuck? I don't think it's stuck. I think it's just slow. But man, how to fix it? Delete all the JavaScript code? What's up, undefined? Hey, hey, hey. Is it doing anything? Yeah, it's TypeScript. It's TypeScript. That's what you want to do with your JavaScript code at work? Yeah, I feel that, man. I truly feel that. But unfortunately, I mean, it's not unfortunate. It's like, this stuff's so important. It's just, it takes a long time to build. So I think that the true solution would be find a way to build it faster. Can't delete it. I mean, the web is kind of how the web goes around, you know? It's like it's a little bit important, you guys. Just a little bit important. So we're going to go ahead and run the database and see what happens. I bet everything will fail. All right, it completely failed. So let's finish the prediction and say that the outcome would be no. The outcome was no. So I don't know if anybody won any channel points to this because only one person bet, but that's kind of how it works. And oh no, so a couple people bet there. So congratulations on your on your channel points. That is hilarious. Okay, truncation resulted in empty batch. So let's there's got to be some unit tests for this thing that I just am completely ignoring. So let's go ahead and check out the unit tests here. So truncate test. So truncate, I think what we have to do here is basically say batch is equal to BA plus. We have to say start key adders is equal to make roachpb.key, comma, len original dot requests. We're going to say for I in range gold and original. Maybe we should actually do it like this. Okay, so we set this like this, and then the start key address is going to be like this. Then we say for each of the things, we also say start key adders original dot start key adders of I dot is equal to request dot get inner dot header dot key. Okay, so we're going to try this. We're going to run the KV core test. We're going to say make test package equals package KV client KV cord. Why would you need to recompile the TypeScript if the changes are only in the Go code? I think the reason is that I hadn't recompiled the database since I rebased it onto the latest master. Okay, so the problem is I just didn't need to make some similar changes to the batch request. Got something weird in my throat. Okay, so here we've got to just say batch request.add args. I think we need to say I think it's kind of the same idea here, is that we should recreate this. Len test dot spans. And then we say test dot, or we say start key adders of I is equal to span dot key. Start key adders. Start key adders. Okay, and then we get to send our BA plus. Okay, so let's try that now. see what we get. Presumably this will fail, which would be nice because then we could know what to fix. Okay, so truncation resulted in an empty batch. So let's take a look at test, just like the simplest test that we could find, which is presumably what? I don't know. I mean, everything looks completely broken. Everything looks completely broken. What is this basic test here? Is this just called test truncate? Why don't we just run test equals test truncate to start with to see what we get here? Okay, so I also just want to run kind of like this. I think we have to go like this to just get the test truncate on its own without any tests that have the prefix of test truncate. Okay, so here we have a very simple, very simple output that looks completely wrong, so we can take a look at it. Expected resolve intent range, blah, got something else. Truncate mutated original. Expected actual, expected actual. But these all look exactly the same. So I'm thinking that something about this. If reflect.deep equal original versus golden original. Oh, okay, so the problem is that this original thing is getting set to the batch rec plus, which doesn't make sense. So what we need to do is set the original to this, just like we had it before. Original is equal to like this, and then we've got to say BA plus is equal to blah, 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 original, like this. I think that should fix that particular problem. But yeah, BA plus, and this is going to be BA plus. Okay, so let's try that one more time now. Okay, so that actually passes, which is slightly odd, I want to say. So let's go ahead and run with a different test here, like, I don't know. Let's just run all the tests again to see what we're missing. Or just test truncate like this so we can get the other truncate tests with a prefix. Okay, so this is failing now. It's getting test truncate with span and descriptor. So let's take a look at that. Test truncate with span and descriptor. How does this work exactly? It's complicated and it goes through the DistSender.send. So it's quite a big integration test, which is actually nice. Why don't we just run this one? Test truncate with span and descriptor. Truncation resulted in empty batch. Resulted. Let's take a look at that. Resulted in empty batch on blah blah blah. If len positions is equal to 0 and error is equals to nil. So that's my issue here, is that we're getting a sketchy and broken situation. We're getting a sketchy and broken situation here. So I think what we should probably do at this point is just step through using the debugger. That seems like the very easiest thing to do. So why don't we just go ahead and do that? We're going to start test, truncate, span, and descriptor. So why don't we just go ahead and run this in debug, and we're going to stop right at DistSender.send. So right here, and we'll see what happens. So this is going to be interesting. We'll step through our code and basically see what we did wrong, and hopefully that's going to help us quite a bit. Hopefully. Okay, so here we are in our debugger. We've stopped at DistSender.send. We're going to step in. We're going to step out. We're going to step in. See what's up. So we're going to skip a bunch of stuff here. I guess, what we could really do is skip down to where we get to this spot right here. So we're going to, why don't we just continue until we hit this. If with parallel commit, and I don't think that that's going to be on here. So we're going to do divide and send batch to ranges. Okay. So we'll continue on in here. Reverse stuff, range iterator, ri.seek. Do we take the fast path here? No, we don't. It's not unsplittable. We skip some checks. We do some stuff, skip some stuff. Defer, can parallelize. Okay, so this is really where we should put another breakpoint in this little range loop. And the very first thing that we're going to do is called next. And so let's see if next gives us anything useful. Seek key is non-zero, so that's nice. We did good. And then we're going to jump right into send. Crap. I think I stepped a little too far. Okay, so what we need to do is we need to break in send partial batch as well. And send partial batch async. Actually, we only need to break in send partial batch. So we only need to break here. So actually, we're just going to restart and basically jump down to send partial batch. Understanding what's going on there. So continue. Here we are in send partial batch. So we continue over this. And does it need truncate? Yes. And we truncate. So here we are inside of truncate. Our batch request has a size 2 start key adders. And they're both set to something different, which makes sense. And what do? So we for each of the requests, we check if it's nil. It's not nil, so we do truncate 1. And what do we get back in truncate 1? I guess we should step into this, step out of this, step into this. So we grab the key from the start key adders. If it's a range, so it's a point request now. We set it to nil. Do keys.adder. Do contains key, return. What just happened? We fell into this span. So, okay, so we're ignoring this one. Oh, you know what we did? I see the problem. Okay, simple mistake. Simple mistake. This is not quite right. This is a point request. We can't consume it yet. We actually have to wait until we are going to actually consume it, which is right here. So this is the key thing. Okay, so let's try again. Let's actually just run the test again, because I feel like that probably would have fixed the problem. Yo, Lithium, what's up? It's nice to see you. Good to see you. It's been a little bit. I hope you're doing super. But there we go. Look at those tests passing. That is actually so cool. So let's take a look to see if any of the other truncate tests pass. Okay, so we still have some problems. Not too surprising. Test truncate with local span and descriptor. Test truncate with local span and descriptor. So why don't we just go ahead and run with this guy as well. We'll do a debug. And this one is doing what? It's doing kind of the same idea. It's doing a DistSender.send. So we'll break there and see what we see. So we'll continue. Parallel commit is set to false. Okay, so we can continue. Here we are in our first iteration of send partial batch. So our batch request has one key in it. So one request, one key. Our request is a scan. Okay, so our request is a scan. Let's see what happens. I can close this. Let's see what happens. Basically, what we want to do is jump down to truncate. I think we want to jump down to truncate. If needs truncate. Okay, so let's jump. jump, 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 jump. Okay, so let's get into truncate. See what is coming up inside of truncate. We should probably even just set a breakpoint here inside of truncate, so we don't have to keep doing this stuff. So we're going to set a breakpoint right here. So let's take a look at our requests. Our start key adders is not equal to null at this point, so we can skip past this. Jump, take a look at this truncate one. So it is a range. So how do we know what's going on here? We do some crap that's confusing to me. We determine that it's local. It's a local span. I still don't know what that really means, to be perfectly honest, but that's okay. So we skip this thing. And we skip this thing. So if so end key adder is not less than rs.end key. And then we say, next time we look at the request, we'll only have to consider the right-hand span, right-hand side of the span that we just processed since we've chopped off the left side already. And let's take a look at header.end key. Like, what does this even mean? Header.end key is some random thing. Well, this is confusing. So we do a bunch of stuff, whatever, we quit. Now I'm kind of lost. Where are we? Well, the thing ended and it passed, which is really confusing. Don't tell me that it's don't tell me that it's non-deterministic. That would be weird. That would sure be weird, wouldn't it? Oh gosh. So it sometimes happens and it sometimes doesn't, huh? Well, why? Huh? Is it something to do with these metamorphic constants or something like that? We'll run with verbose so we can always see these constants, and maybe we'll see something that pops out. Oh, you know what it probably is? It's because there's some asynchronousness going on in here. And that's probably what the non-determinism is. But I don't... Oh, is it because... Is it because we run this thing async? Like... Is it because we run this thing async and then there's a race in truncate? That is the issue, isn't it? There's a race in truncate. Gosh, that's really annoying. Oh man, that's so annoying. Oh. I am unhappy about that, to be honest. What do we do? What do we do? Hmm. So I think the key thing is this token, right? No, this is an eviction token. How do I know what the current... It's the current range that we're talking about, right? It's like that's the span of things that we're caring about. But where do we get that from again? Truncate BRS. So it's this RS. rs.intersect routing toke.descriptor. Truncate the request to the range descriptor. So is there any way that we can avoid making this terrible? We could presumably... I mean, we could force all of this processing to happen before the parallelization, but that seems a little annoying. That's one option. But if we send it in parallel, then all of a sudden we're ruined because this whole assumption where we're processing things left to right no longer holds. And that is a that is a major problem. That is an absolute major problem. And I don't know what to do about it. I mean, I guess what we could do is like, well, no, I guess what we do is we truncate outside of send partial batch. I think that's what we do, right? We truncate in this loop. Who calls this? Yeah, I think we truncate outside of this loop. Let's see what that looks like, actually. I'm actually quite curious. What does that look like? Let's take the fast path. If the batch is within a single range. Yo, L Cravo. Are you an L or an I? Let's see. You are an L, I think. What is up? It's good to see you again. It's good to see you again. So let's try to do the truncate outside of the batch. What does that look like? I mean, the very first thing that we do is we do a truncate here. The very first thing that we do is we say send partial batch to the truncate. So truncate the batch. Truncate the batch. And it's really just a small little snippet. So let's just grab this and put it back over here. You know, we should make a function for this though, for sure. So we're gonna make a function. It's gonna be next to send partial batch. Truncate batch. Error. So it needs to have an rspan. Needs to have a routing toke range cache dot eviction token var error. And it needs to have a batch. It needs to have a batch plus. BA batch plus. And it needs to have this position stuff, presumably. It needs to return the positions, and it needs to return the batch plus. So it needs to return Patrick plus. Positions is a list of int and then an error, right? So here we have return ret nil like this. I guess this is just errors.new now. Errors.new f Huh. Return error. Return ret no error. Then now we return BA positions error. Okay, so how about that? We do our truncate batch. So we can get rid of this thing over here. We're going to say, hey, JB Pratt.
Relational databases don't scale because they use joins.
Batch request,
joins,
rspan, ri.token. Thank you so much for the 8 months. Really appreciate it. Welcome back. Hope you're doing well. So we're going to say batch request. Ooh, but we need to somehow thread in the positions into this thing now, don't we? That's okay. So that we'll just thread those in. So we'll say BA positions error bar error error bar positions int. If error is not equal to nil, we basically say resp.error. I don't know, what do we say here? Normally what we would say was what? We said we'd set the p error to roachpb.new error of error. So we have to say something like oh, we can return normally from this. We're just being weird about it for something. So return nil, comma p error. So we say return nil roachpb.new error of error. Okay. And then this thing needs to start to take in a positions list, which is fine. So instead of needs truncate, why don't we just pass in our positions list, right? Positions int like this. All right. And so here we're just going to pass nil for positions. I think that's fine. I think that's what we did before. We would never set it if we didn't need to truncate. And then the last case is this one. Here we just need to pass in more stuff. Yeah? Oh, right. And we need to also run this here. I think we can do it up here, in fact. All right, so let's try that. Let's see what happens now when we run this test. So it's going to change the character of things a little bit because it's not going to let us parallelize any of this truncation, but hopefully this truncation will be cheap enough so that we don't have to parallelize it. Now it looks like it never finishes, which is probably worse. Probably quite worse, huh? So that's cool. What about if we just run the simple case again? Hold on, I need some more water. Uh-huh. All right, so test truncate normal works okay. So what about test truncate with? So yeah, it kind of just hangs. I wonder why that's happening. Why would this be hanging? I guess we can... Oh, you know what the reason is that we can't be setting this. We need to say a new batch. So right, new batch. Yeah, it's Goland. It's Goland. A new truncated batch request. Yeah, so the issue is just that I've got to make sure to not edit this thing. We need to say like cur batch. You got to use, I mean, I really like Goland. I think Goland has a student discount. If you're a student, you might be able to get it at a low price. And if you're not a student and you're working professionally, you should get your company to expense it because this thing is so good. You've definitely gotta push for your tools. Okay, so now this is working. Hey, so that's great. So now let's go ahead and run all the tests. You're Brazilian, is that's equal to poor? Well, are you professional or student? Or neither? Hobbyist? Student? Free educational licenses. Learn and teach coding with the best-in-class development tools. Individual licenses for students and teachers. Get free access to all JetBrains IDEs for personal use at school or home. Who can get free individual licenses for education? Students and faculty from accredited educational institutions are welcome to apply. You don't have a student email. That is tough. I think that is definitely tough. You might just try this out. Maybe this will help you. Maybe this will help you. Documents. I don't know. I bet there's some way to do this. If you're really a student. If you're not really a student, then you might be tough. You might have a tough time. How come you don't have a student email? Out of curiosity. I never sent it to you? Test multi-range gap reverse seems to be hung. And this one seems to have been really slow. You study on a high school that is kind of a school. Okay. Well, try to see if you can work something out with this. I don't know what ISIC or ITIC is, but maybe there's some way to make this happen for you. Level of study, secondary. Oh, that teaches you IT. Official document. You should send them. Do this one. This one seems good. This one seems good. It may take 2 weeks, but you'll get it. Look, you put your address, you put your academic institution, and then you send some document that proves your student stuff. So it's like you scan your student ID or something like that. Try something like that. Try something like that. Okay, so test multi-range gap reverse. What does this even do? What does this thing even do? Hmm. Hmm. So basically this thing is doing ds.send. Why don't we can use the debugger. We'll stop here and see what happens. So here we are in ds.send. We'll continue. We'll get to for len parts. So we'll continue. Here we are in our ri.valid loop. So how many things are in this request is the question. I've got a BA, I've got a batch request, and I've got two things in it. Start key adders, len2. len2, 97 and 99. So it shouldn't be so complicated. Here are my requests. They are there's one reverse scan request and another reverse scan request. It does use delve under the hood. Exactly. So these are reverse scans and they have end keys. Okay, so it's a reverse scan case. That kind of makes sense. I had a feeling that the reverse scan case might be kind of broken. So it sort of makes sense that this would be a little bit busted. So we continue down into here. Whoops, I shouldn't have skipped continue here. But anyway, so here's my ba.requests. ba.request is now still the same thing. Oh, you know what I think the issue is? TLDR about this overall project. You can read about it in CockroachDB command. This particular project you can read about in this issue. If that ever returns, which it may not. There we go. Yeah, Goland is really, really nice. S. Brabez. It's extremely good. I could not recommend it more, to be perfectly honest. It's extremely good. It's just very, very good. So we've set 1 to nil here, which seems good. So we skip 1, and the next one we go into truncate 1, and the result is has request is set to false. So I guess the issue is that we get into this loop where nothing ever gets returned. And then what happens? We get truncation returned empty batch here. Okay, so the problem here is just that we get an error back, and then for some reason that never does anything. It's kind of odd. But it's actually kind of interesting because in the test, I believe it said something about this, didn't it? It said, before fixing this would error with, well, it looks like I've regressed it. Huh? Oh gosh, okay. Fix the horribly broken prev. So presumably I just broke this prev thing a little bit. And it makes sense because I don't understand these reverse scans as well. So it's got to be something wrong with whatever I've done in this prev thing. So let's run it one more time in the debugger. I think I'm actually gonna have to leave in a little bit, unfortunately. Looks like we're not gonna quite finish this project in time before I've got to run, but we'll do it next time. So here I am in my response channel. Here I am in my requests. And whoops, I think I went a little too fast there. Okay, so here's our first request. We skip this, we get truncate 1. This is set to false. Okay, so the problem here is just that we just leave and we set everything to false, but we've still edited the positions to be nil. So that is the problem here. That is the problem. We need to figure out what the deal is with that and fix it here. If we return false, we should never be setting that value is the thing. This case, check whether the transaction has left any keys in the range. If not, we need to cut it out of the request. So I think in this, yeah, basically, ooh, so it's a little tricky. We basically have to say, we want to say like var consumed key is equal to false. Here we say consumed key is equal to true. And then we down here say if consumed key, something like this. That might fix it, but it also might not. I'm not sure. Let's find out. So I think it actually did fix that one case, but now we're stuck at a different case. So we're making some progress, which is cool. But now we're getting failing on test range splits with concurrent TXNs. Well, I think this is probably going to be a good time to leave it off. So here's what I'm going to do. I'm going to make a little new commit, whip, or we'll call it linear or sub, or we'll call it fix, truncate, and next. Git add 1, 2, 3, 4. We're going to say git commit. Whip, KV chord, improve truncate, and next. Previously, truncate and next were quadratic. Previously, the way the DistSender invoked KV was quadratic. Each invocation of these, I guess it's truncate, next, and prev was quadratic. Each invocation of these functions required iterating over an entire list of the entire list of requests in a batch request to check whether to either find the start key. Yeah, it's sort of like find a start key, or to find all requests that intersect with a given range. However, we can do better. We can process the batches sequentially and edit them with and sort of keep track of which parts of the requests spans we've chopped off and used already. By doing this, we can skip doing extra work for those already used span portions. This reduces the complexity of the loop to, I don't even know what it is. I mean, I still think it's, the loop in this case will remain quadratic, but it's kind of, I don't know what it is. I don't know what you would call this kind of loop. It's kind of amortized since we reduce the set of things to check on every iteration. There could be a better way of doing this still. Yahor suggested a interval tree, but I'm not quite sure, and it's complicated. Okay, so release note, we'll say none for now because we're not going to merge this. So we'll just push this thing up. Push this thing up, and we're going to tag Yahor and Nathan, and we're going to say touches whatever this thing is. 68,536. 68,536. Note, this is not working yet. It is definitely still buggy. It's just one idea to fix the issue and may not be optimal. I think an approach like this would solve much of the wasted CPU, yet it doesn't truly reduce the complexity of the algorithm in a way that would be ideal, since we're not sorting the requests or using a tree, etc. We're just marking ones that have been consumed and skipping work that has already been known to be used up. Also, finally, we had to remove some concurrency. It used to be that truncate itself could be run in the async task, saving some serial work. But doing this makes it very hard to coordinate the work so that ranges can skip iterating through things that have been done already. So we've moved out the truncate into the serial component for now. Yeah, the draft PR stuff is good. It is better to have a smoke test. But the thing is that draft PRs also run CI. At least it does on our CI. I don't know if we are missing something, but that is that. Okay, guys, that is gonna do it for me. Unfortunately, I do have to run, but it was really great to hang out. So have a good weekend. We got a little bit done. We didn't totally finish this project, but it was nice to get started. It was nice to take a look, and honestly, it was nice to just hang out with you guys. So I appreciate it. I will be back next week. The stream will probably be a bit weird because I'm not going to be by my computer. I'll probably do some sort of like goofy IRL thing just to say hi to everybody like I did last week. But after that, I'll be back for a long stretch, and that's kind of that. So let's go ahead and find somebody to raid real quick here. Who should we raid? Who should we raid? Why don't we go ahead and... Ooh, how about this? This is going to be fun. Okay, let's raid this person who's doing some Rust stuff. No problem, guys. It was really good to see all of you. We're going to give a raid to this Rust fellow, and hopefully it'll be really fun. But Yeah, they just actually started their stream. So, oh wait, did they start their stream? Oh my God, no, they've been streaming for a super, super long time. So they've been streaming for a long time. You guys give them your support. And yeah, you guys have a great weekend. Have a great week. I will see you next week. Goodbye.